everyone. Let's see if I can move the slides. Cool. Oh, yes. Okay, so anyone here knows what HTTP headers is?
Yes, it's a module that sucks.
Yeah. That's a workable definition. Anyone thinks this is anything to do with parsing HTTP or getting that kind of stuff? It is not. Okay, so HTTP headers is just a glorified hash. It stores headers and its values. That's all it does. The reason for its existence is that it's used in HTTP processing whenever you get a request and you have to work with the data you have. And the purpose of what I'm going to show to you today is getting a better implementation of this class, where better is particularly faster. That's our main goal here. So, how do you use HTTP headers? You're going to see that this is very much like using a hash. So you create a new object of the class, and you can set headers to values. You can get them back, and you can remove whatever you added. There are certain things above a simple hash table that you can do with HTTP headers. So for instance, you can set more than one value for a specific header, and you will store all of the values in it. So it's kind of like a multi-valued hash. So when you ask back for Hobbit, you will get both Bilbo and Frodo. You can also add values to whatever keys you already have in the hash. So you can push more Hobbits in there, and you'll get back all your Hobbits. And of course, when you remove that, you don't get Hobbit anymore. When you ask for the field names after that, you get only Wizard. And you can clear everything in it and go back to square zero. So that's pretty much, that's like 80% of what this class does. It has some specific knowledge of standard HTTP headers, and it does some specific things with the names that you store there, like capitalization. It's all treated in a very specific way, which is geared towards processing HTTP headers. So, this class is quite old, so that's good. It's stable code, so let's be positive about that. It's very simple. It's a couple hundred or a couple tens of lines of code. It's stable and it's used pretty much everywhere, and it's pure Perl, so that's good because it's easy to understand and to modify. And it uses a hash as a container, and in that hash sometimes it stores single values as scalars, sometimes it stores an array of values whenever the key that you are storing has more than one value. So, the good thing is that it uses a hash. So we know hashes work in Perl, and everyone pretty much trusts their life to Perl with Perl hashes. And the code is really simple. So those are good things. Now one of the bad things about this class is that it uses a hash. So it's both good and bad, because a hash is kind of not the best way to store all this information. And I'm going to show you a couple of examples later of where you can see the seams in the fabric here. And the very simple code also means that there are some quirks in the implementation. So there's a lot of, if you see the code, there's a lot of testing for, do I have a single value or do I have more than one value? Because if I have more than one value, I have to go to the array ref that's stored over there. So the code is not really that clean. And then, this is the main concern for this exercise, it is not fast enough. What is fast enough? Well, it always shows up in our profiling output for everything related to HTTP processing in Plack. So we wondered if we could find a better way to do this. And there's also some stuff in there that you wonder, why is this in here? Things like, I'm going to give you just one example. Header names are normalized so that the first letter is uppercase and the rest is lowercase. But you could start a header name with a colon character and it'll take it as is with no normalization. Looks cool, but it's totally useless, and it's not used actually anywhere in CPAN. We actually did look, and so you wonder why it isn't there. So we were not the first to notice these things, and someone else created HTTP headers fast. So I'm not going to try to read those names, but the second one you may know is the author of Black, right? So this is serious work here. And what he did was, let's see if I can re-implement HTTP headers in a more clever way. So he stuck to exactly the same interface, still pure Perl, and he replicated every single detail about HTTP headers. So it works, you will never know that you're not using the original class if you use this one. So we think it's gooder, it's stable, and it is in fact used internally by Black, so definitely this is good enough. Regarding usage, same usage as HTTP headers, there's no difference at all. And this was a design goal, specific design goal for the class.
Only from the last version. The previous ones were missing some functionality.
Okay.
Flatten wasn't there.
So maybe we can consider that a kind of like an improvement of the class in time, right? Until it became exactly the same. So again, what's good about this class? It uses a hash as a data structure, and it trades off the simplicity in the code for speed. So there's more weird stuff in the code that you have to sit down and understand why and what he's doing there. And it's all in the name of speed. So one of the things he does is he has different code paths based on how many arguments he's receiving. So if you're setting a name, a header, with one value, you go through one code path. If you're passing it an array or several different values, it goes through a different code path, which is the way he found to make it faster. So that, again, still we keep to the hash, so there's really not much more to be had out of a hash other than what he's doing here. And the fact that you trade off simplicity for speed is also the source of problems, because this code is more complex. So there are more bugs to be found in here. They may already have been fixed, but who knows, right? And we think it was still not fast enough. And all the quirks, the column thing, there's another thing called translate underscore, and other things that I'm not even going to mention, they're all in there. So carried over. So at this point, a couple of months ago, we created here at Booking.com the Perl 5 Porters Club. So it's just a bunch of guys who don't know anything about Perl. Well, that's me. Some guys who know a lot about Perl, and we are trying to find ways of learning more and having fun, and also maybe finding useful stuff to do. So we were looking for a project a few weeks or months ago, and Rafael mentioned, maybe you guys can move part of the headers fast implementation to XS. So we said, oh, cool. So we did, and we moved, I have them here, several of the public-facing functions of HTTP headers fast. We moved them to XS. So it was P5P Club who wrote this. And we wanted, again, to keep the exact same interface. So we set ourselves that constraint. We migrated some code paths to XS. And the way you use this new class, again, exactly the same. No change. So good about this. Still a hash. That's still good. And it is faster. I don't really have the latest benchmarks because you're going to see that it's not the latest work we have done. But I remember, and maybe Sawyer here can call me a liar if I'm wrong, I remember we hit about 80% faster with this. So this was, for the most used cases, it was quite a good improvement in speed. Of course, a couple of bad things. Again, not fast enough. We actually expected more. We thought, when we move stuff to C, this is going to fly. It's going to be, I don't know, 5 times faster. And it was kind of a surprise that it wasn't. So, not fast enough. We're still inheriting all corner cases, and this is just because of the way it's implemented, right? We just took a couple of the functions in headers fast and re-implemented them in C. So everything, the interface, everything that worked before works the same way, but with a few faster pieces. And that's, in my opinion, the worst of the bad is that there's a lot of complexity in this XS code. So this is the ugly. This is not even bad. This is really ugly. Do not try to read that. It's there only to convey to you the idea that reading this code sucks, because you look at that and you're like, oh my God, what the hell are we doing there? I'm a CE hacker who's been learning Perl for 1 year now, and who's been learning XS for a couple of months. And I saw that and I thought to myself, there must be a better way to write XS. I don't want to deal with that code every single day. Really. I mean, that may be bread and butter for you guys, but for me, it's not nice. So, at this point, some of us in P5P Club were wondering, maybe we could just leave everything behind. You know, if we break compatibility, full compatibility with HTTP headers and fast and XS, and create our own stuff, maybe it's worthwhile if we get a better improvement in speed, and we can still use that from Plaque. So that was our basic goal. If we can replace what we have today in Plaque with this, if we can provide enough of the interface that the older library provides to Plaque, maybe we can make it easier to work with, faster and better. So this is our, for P5P Club, this is our second iteration. And again, written by the club, we completely reworked HTTP headers. We set ourselves those goals, being fast, lean, and clear in the implementation. We didn't try to implement the original algorithms or data structures. And we tried to push a lot of implementation to pure C. I'm going to go back to that because in my opinion, that's one of the lessons learned, how to separate stuff that is pure C from stuff that has to be XS, because it has to provide you with the glue between Perl and XS. So the interface is mostly compatible. It's actually 99% of it. There's a few things that work differently, really minor details. But you will see later the usage. So a couple of the things we left behind, we don't have support for that. So you can, the thing there, the translate underscore is because usually HTTP headers separate words with dashes. But if you use a dash in a hash key name in Perl, you have to use quotes. So in order to be able to use underscore and not use quotes, we translate underscore to dashes in C. But the original library had a way to say, yeah, I don't want to translate. I want to use underscores and keep them on underscores. And that's totally useless because it's not used anywhere. So we got rid of that. We always normalize the header names, and we don't have the column thing to use literal header names. So the usage, pretty much the same for all intents and purposes. Yeah. So actually I have not found a case where it works differently. But since we're not implementing 100% of the interface, we know of certain test cases that will not happen. We don't care about those. So one of the things we had to decide when we did this is how do we represent a set of headers like I described in C? What is the best way to do this? So all kinds of ideas come to your mind, you know, like linked lists of things or hash tables or arrays or whatever. And it is not obvious which of these implementations is actually the best. So we tried 3 of them. And I put them there unsorted. So these are not the order in which we tried them, and I'm not telling you not telling you yet which one won. And I am asking you which one you think is the best implementation for this use case. And I'll let you ponder that for a couple of seconds.
Well, it depends how you do it internally.
It depends on?
We were discussing Q.
I was saying it shouldn't be Q because it would be too hard to put stuff in.
Uh-huh.
So Q should be last, I think.
Okay.
You should just never.
R is what you already had. Right.
So how many of you think P should be the way to go? 1, 2.
So
How many of you think Q?
Well,
Kind
I'm
of-
gonna go with Q.
You're going to go with Q, okay? So more people
Here's my
think
life.
R. Hash table. How many think R is the way to go?
Sure.
We would call that the winner, right? Okay, so we tried first that because it was easier and it was obvious that we could do anything we wanted with that, and it worked. And then we measured performance and it sucked. It was awful. But one thing is that at this point, this was pure C code. So just by changing the implementation on 2 C source files, we could switch the data structure and everything else, the test suite, everything worked the same. So big lesson learned, relearned. I guess this, you learned this in college, right? But it's good to revisit those lessons. So after that, we tried the hash table, kind of thinking, yeah, well, okay, let's do it right. Hash table has to be the right way to do it. And it was better, and surprisingly, it was not that much better. Which got us thinking, and one of the reasons it was not that much better is because we're not storing 10,000 names in this thing. We're storing tens or maybe hundreds of header names. Most of them have 1 value. Some of them have more than 1, but most have 1. So when you look at that use case, the overhead for a hash table starts being a lot. So then, it's funny because I decided to try that after a comment made by Stephen, who just said that hash table was the best way to do this. So Stephen said, maybe you should try a dynamic array and auto-grow it if necessary. You did that. So.
Is that tricky in C? I don't know C very well. Is it hard to make a dynamic array?
Well, you have to manage the memory yourself. So it's basically you allocate the array dynamically, and you remember how big it is. And whenever you have to grow it, whenever you have run out of space, you just, what we do here, we double the size, and we copy everything to the new array, and we drop the old one. So it looks like a lot of work, but what you get out of that is that everything is consistent. So access is really cheap, and you get one more advantage that I'm going to mention soon. So, in case it's not clear, this is what I mean by dynamic arrays. So we have an array of names that grows down, and we have for each name an array of values that grows to the right. We pre-allocate a certain size, I don't remember how big, maybe 4 elements for each array. And every time we run out of space, we double the array. So it's kind of obvious that, for instance, name 1 grew once from 2 to 4, or maybe twice, from 1 to 2 and then 2 to 4. And name 6 is a good example for the case where you grow from 1 to 2 and then you erase one of the values for that name. You don't shrink the array. We don't do it. It doesn't look like something clever to do. So, a couple more details about the implementation. We also know all the standard header, the standard HTTP header names. This allows us to group them, sort them in a preferred way, which is the way that's written in the standard. And also, it allows us to handle casing, because the standard says, yeah, this is the casing is usually first uppercase, the rest is lowercase. But if you find over there, there's a couple of weird cases where that algorithm is not going to work, right? We got tests failing because we had uppercase W, lowercase w, which is not what the standard says. So this allows us that kind of fine-grained control. Using the dynamic arrays also allowed us to move the sort function, which sorts by name, from Perl to C. Because, to move it from Perl to C in a efficient way, just using the standard library qsort routine. Because since we have an array, and we know how many elements we have, we can just sort it with qsort. And that's a lot faster than sorting this in Perl, which has a lot of movement, memory movement, and pointers moving around. And as a final note, this kind of monstrosity Perl, when you have a header value that has new lines in it, and you want to get the headers as a string, you process the values so that they follow that algorithm, which is basically the first line, then a new line, and then you indent a bit the second line, and then all the lines are indented. And to do that in Perl, the code in HTTP headers and headers fast and headers XS too, uses those regular expressions, and that's really expensive. And all of that was replaced with 40 lines of code that has this exact knowledge to do exactly that and nothing else but that, and which is much faster. So, results. What do we get out of this? It is much faster than the original. Depending on the benchmark that you run, it's between 1 and 10 times as fast as the original. So that's a big win for what we were looking for. The fact that we are doing this in the open, of course, in the GitHub, and we're packaging this on Meta CPAN, allows us to get help from the community, and someone already chipped in and realized that our code was not thread safe, so in Windows it didn't work properly, and they helped and fixed it. And we are now starting to test this in our live environments in Plague. Don't have any breaking news to tell you about it, but we are, we think it'll be good. So, conclusions. API definitely matters, and this is kind of like the bottom line of this speech. At all levels, API matters. Trying to get behind an API that's already designed may not be always a good idea. Sometimes you have to break with the past if you think it doesn't make sense. And the way you design and create software, also it is a good idea to have clear barriers between, in this case, Perl and XS and C. that allowed us to try several different implementations and keep reusing the test suite and adding to the test suite and making sure that what we were doing made sense. Perl is definitely fast, so many times it doesn't make any sense to move away from Perl, but sometimes it does, because XS is faster. So if you implement something in XS and you do it properly, you do it well, and you take care of not crossing the boundary between Perl and C too many times, you will reap the benefits. So bottom line, good API, good barriers between Perl, XS, and C will lead you to good results. And you will profit. So, that's it. Well, people there, Raphael inspired us to do this, and Sawyer helped a lot during the implementation. Christian Hansen is the guy who fixed the multi-threading problems. P5P Club will work on this, and Alex is my wife. Any questions?
Yes, one. Can you go back to the dynamic application diagram?
That?
Yes. Just one comment slash question. You said that I believe that in Batchworks is much faster than the original, but you do want to optimize for black.
Yes.
And you are
Can you speak a
aware
bit
of the
louder?
fact, sorry. In black, you always have one value. You are aware of that.
No,
Bec-
I'm not aware of that.
Okay.
I'm not saying you're wrong.
No.
Sorry.
I'm saying it in the sense that it might require a different optimization.
Okay.
Yeah, when Plaque gets the HTTP request and it transfers it into the PSGI environment, it doesn't, you don't get the headers, you don't get a set of headers. You get one header that's, was it?
It's one string concatenated.
Yeah, it's
of
like
all
a
the
comma
values.
separated string of all the values.
Okay.
Is that Plaque request, the Plaque handler?
That's
HTTP
PSGI.
request to PSGI, I think, or whatever.
That's by the PSGI standard. So,
Okay.
Yeah.
so,
If Plaque.
so if you want it faster for black, you maybe want to consider optimizing it for one value.
Oh, definitely. The way we arrived here was by benchmarking and running
Yeah, yeah.
tests and
Yeah,
comparing.
absolutely.
And every time you get closer to the environment that you're actually going to run in, yeah, you may find that you need to change stuff. So one thing else that still I think needs validation is, does it make sense to have just the names in an array? Because if you have, if Plaque handles hundreds of headers, that means that to search for one, you have to either go over the whole array or sort that and do a binary search, which may be perfectly fine, or it may suck. And we have to see that running in Plaque and see where the,
Yeah.
You might be able to use like a tree, TRIE structure or something like that. to fast search as well.
which some people call try. Yeah, okay.
In the black environment, it also pre-populates some of the values, like content type, stuff like that, so it will do searches after parsing.
Uh-huh.
So you also consider that.
Yeah, yeah.
Makes sense.
So if that is the case, it might make sense to go back to a hash table. I really don't know, because I have not seen the numbers that show, yeah, we need more than 20 headers in black, or more than 100. I don't even know what the sweet spot is.
I don't think it's limited, and I tested it.
Yeah, I know, but I want to see a histogram of, 80% of the requests use 5 headers. Okay, then forget it. We keep to that.
Yeah.
So,
I have another question. You showed the 3 possibilities for C, and you said the first one sucked. How did it suck compared to Perl? Was it faster?
okay, good question. From the top of my head, it was faster than Perl, but it was not faster than the HTTP headers fast XS library that all it did was keep the hash and manipulate it with C. So it was slower than that,
Oh, okay.
right? You can correct me if I'm mistaken. It's been,
And
it's
was
been
it,
so
was it
bad.
the linked list or the hash table?
That was with the linked list.
Okay.
With the hash table, we got to pretty much the same
Okay.
as manipulating the array from C.
I think it was slower than the pure poem version.
The linked list
That's what bugged us the most.
is may have been, yeah. Yeah, maybe. Yep.
We talked a bit about like the relative benchmarks. I'm curious what the absolute benchmarks were, if you have that information off the top of your head, like how many thousands of requests per second with the different algorithms?
Not from the top of my head, but they are in the package
Okay,
page.
okay,
We do publish some comparative results between this and one of the previous versions.
I'll check it out, thanks.
So, yeah. Yeah, sometimes one of the things I hate about the way we publish benchmarks is it says, yeah, this is 37%, and that doesn't tell me anything. So I just look at, okay, so how many headers did I process with this and with that, and okay, twice as many.
I
Okay.
imagine you're dealing at the scale of milliseconds here, right? Per request.
Even less, yeah.
Yeah, because each, I mean, yeah, naturally there's, the headers are a pretty lightweight
Yeah,
part of this given request.
yes. Anyone else? Well, thank you.